Yeah.
I'm sorry?
Oh, we post on Facebook.
Oh,
Yeah.
all right, so on slide number 3, traditionally, what are NPN substances used to monitor?
Metabolic.
Renal function.
Renal function, yes. Yes, yes, yes. On slide number 5, I tell you that 60% of the urea is excreted and 40% is reabsorbed, yes. On slide number 6, what is the azotemia?
Increase.
Urea in the blood, yes. How do you fix pre-renal conditions that's causing an increased UN? Sorry? Solve the problem, fix the problem, yes. Yes, yes, yes. Okay, slide number 9. What is the normal value for BUN? 6 to 20. And what is the name of the enzyme that measures your urea level? Urease, yes, urease. Which is just urea, S-E.
Can you go back up? I'm sorry.
Sure.
Slide 6, what did we do on slide 6?
Slide 6.
The first thing you mentioned.
Slide 6, azotemia is an elevation of urea in your blood, not in your urine, it's in your blood, right? And for pre-renal causes of increased urea in your blood are reversible and can be, all I have to do is fix the problem. Whatever is causing the increase, you would fix it, congestive heart failure or whatever, if it's easily fixed. So it's VUN 6 to 20, urease is the enzymatic method. So your BUN creatinine, why do I want to do a BUN creatinine ratio? What will that tell me? What is it basically assessing?
Pre-renal or post-renal?
For pre-renal, post-renal for what? Urea? Is that what you just said?
Uremia.
Urea, yes. Your BUN, what? Right, you're right. It's just, I have a hard time hearing you, I'm sorry. Okay, so for creatinine, you're gonna know, so I'm on slide number 11. You're gonna know the normal value for creatinine. You're gonna know that it is filtered and not reabsorbed. And that it is, let's see, secreted into plasma at a constant rate relative to muscle mass. There you go. I have a star floating out in the middle where I was wondering. Okay. For the analysis of creatinine, slide number 15, what is the reference method for creatinine? Jaffe reaction. And what is your reagent? You got it. Alkaline picric acid. Okay, uric acid. What disease are we looking for? Well, why would we measure an elevated uric acid would indicate what disease? Yes. start by primary and secondary, but I don't think I have a test question. I'll have to relook at the test on that.
What was the, what's the?
Gout.
Gout.
Uric acid is gout. The uric acid analysis is uricase. Enzymatic reaction is uricase.
What side are we on?
19. Normal value 2.6 to 7.2. Then at the bottom it says gout, and I'm on slide number 20. The gout is the clinical manifestation of uric crystal deposits in connective tissue. So one of your 4-point questions on this test is you have urea. And where did that urea come from?
Bilirubin?
Deamination of amino acid.
Okay, exactly. It's a waste product, right?
Mm-hmm.
So how does your body get rid of your urea? What's the first thing it's gonna do?
It goes to the liver by enzymes of urine.
Right, so liver, right? And then what's the liver do to it?
It prevents ammonia toxicity.
Breaks down the urea,
Breaks it down, brings it to the kidneys.
takes it to the kidneys. And then you put it back, right? So the flow of urea to your liver, your kidneys, and your liver. Right? Am I right?
So that last
What was
thing
the
is
last
voiding.
Yes. Yeah, you can write void instead of your analysis, that's
Oh, I thought somebody sitting on a toilet.
Okay, let's see here.
So we just have to like know that those four.
Yeah, it's just that. I lied. Okay, so here's where I was going with this. So, your ammonia is where you start, sorry. And then it goes to
Urea.
goes to your liver, right?
Oh yeah, breaks down too.
And then it goes to, which makes it, turns it into urea, right? And then it goes to your kidney. And then you boil it. That's where it was. You did a good one, right? Yes, ammonia is conversion to the urea by the liver. Yes. There we go. That's right. You know, ammonia is neurotoxic. It's going to affect your brain. And then as far as the analysis of ammonia, what is important with the analysis of ammonia?
Quick and cold.
Quick and cold, yep. That's basically a situation question. The specimen came out, whatever, and what you would accept or reject. What do you have markers on the inside, correct? Cardiac markers. What would I know for cardiac markers? On slide slide number 8, we talked about the traditional tests, creatinine, AST, and LDH. Which one rises first?
The creatinine.
Second?
Aspirin.
And last?
And then lactate.
Right, so just remember Al. C-A-L. And you remember Barney, and you remember his grandma Cal, right? All right, on slide number 9, your CKMB. What is it normally?
Below 6%.
Less 6% of your total CPK, okay? When does it increase? So basically, so I kind of tried to put it all in one slide for you to help you study. Slide number 7 kind of takes a lot of the information from the individual slides and I put it on one, where myoglobin, how it rises and falls, and CKMB, your troponin, and I would worry about the troponin T and troponin I as well. So basically, I'm asking you which one rises fastest, how long is it going to be elevated, and if you had a patient who came in with chest pain, what would it mean? So that's a good slide to know which ones do what. CKMB is basically a isoenzyme, right? Fraction of your CK, and it is specific for what organ? Yes. Okay. Troponin T, so I'm on slide 12. Troponin T is more specific in an MI. Troponin I is more specific in a myocardial infarction than troponin T. More sensitive. Troponin I is more sensitive. Troponin T, what I want you to know is it interferes with renal disease. End-stage renal disease can cause an artificially increased troponin T. With your troponin I and T, this is probably on that worksheet. I don't know if you filled it in or not, but it was decreased with hemolysis. Right, troponins are decreased with hemolysis. And why is that significant? Why would we worry about that?
Hemolyzed specimen won't indicate your non.
Exactly, the hemolyzed specimen will give you a false negative, right? Exactly. Myoglobin, increase with muscle damage. We find it in your urine. And myoglobin on slide 17 at the very bottom, good negative indicator. So what does that mean? It's a good negative indicator.
It didn't have.
So if you have an MI, you're going to have myoglobin in your urine, right? If you didn't have an MI, you're not going to have myoglobin in your urine, correct? So a good negative indicator. Increases very rapidly, decreases very rapidly, which again is on that sheet, the very first slide.
What was the last thing? I'm sorry.
It was basically this slide about when it rises. It's the first one that's going to show up, but then it's also going to go away quickly.
Okay.
So if you're that person that had, was out mowing the grass on Saturday and was having chest pain, but you waited until Monday to go to your doctor, it's not going to be a good indicator then. And why do they order a BNP?
Heart failure.
Congestive heart failure is one you think of BNP. Honestly say, definition of an enzyme?
Biological fundamentals.
Yes, exactly. What do I'm on slide number 8. What do oxidoreductases do?
Oxidize and reduce.
Reaction. So give me an example.
pH.
LPH, yes. Transferases, what do they do? Give me an example. Yep. Hydrolases, what do they do? And give me an example. So on the 4-point questions on this test, you're simply going to be able to draw for me enzyme plus substrate plus enzyme substrate complex then goes to enzyme plus product. 4 points. And that's basically the relationship between the enzyme, substrate, and product. Okay. So you're going to need to know the enzymatic kinetics, so the factors that will affect the enzyme reactions. So slide 10, you're going to be able to I think it's a short answer. Yes. So you're going to list 4 factors that influence enzymatic reactions. So things like substrate concentration, enzyme concentration, pH, temperature. You could say cofactors or inhibitors. You're going to list 4 of those for me.
Bless you.
Okay, what's a fixed time? I'm on 12. What is a fixed timed assay?
One reading at one time.
One reading, one time. What's a continuous monitoring assay?
Readings every time.
Right, that's a kinetic assay. Right, correct. So, fixed is one time, continuous is over time. On slide 13, we talked about a zero order reaction. A zero order reaction is depending on what?
Enzyme concentration.
Enzyme concentration. First order reaction, that's the Michaelis-Menten constant, and that's reliant on what?
Substrate.
So which one do we do in the lab for enzymes?
Zero order.
Zero order, yes. On slide 14, it's the definition of an international unit. The amount of enzyme that will catalyze the reaction of 1 micromole of substrate. And a lot of these are on your worksheet, so however you want to study one or the other. But acid phos, you need to know that it's prostate, pH of 5. So acid phos, prostate, pH of 5, and increased with hemolysis. Alkaline phosphatase, pH of 9 to 10. Increase with hemolysis, and increase with bone disorders such as Paget's disease and rickets. and ALT. So AST is heart and liver. ALT is the liver. In the AST assay, what factor do you need? Cofactor, I'm sorry. Vitamin B is a cofactor. AST is increased with hemolysis. ALT has no effect. Amylase, pancreas, acute pancreatitis. Lipase, pancreas, acute pancreatitis. Decreased with hemolysis. Given
Barb, did you mention that we're gonna be able to use our enzyme sheet on this? We're not going to.
sorry.
No, I thought I had heard you say that.
You're gonna use the blood gases worksheet.
Got it.
They're not. Cholinesterase, increased with decreased with insecticide poisoning. Decreased. Insecticide poisoning. Creatinine kinase, again, it's also your cardiac lecture, so, but CKMB is your heart. Elevated with strenuous exercise, hemolysis can cause an elevation. And the sources of error at the bottom there. Gamma GT, increased with alcoholism. Then at the bottom, if I have an increased GGT and an increased alphos, could be liver. But if my GGT is normal and my alphos is increased, then that would tell me it's bone. Is G6PD affected by hemolysis?
Purposely.
No, because you're purposely rupturing it, right? Because that's what you're measuring is the hemolysis, right? Lactic dehydrogenase, LDH, increased with hemolysis. I can either go over it now, or I'll just give you the answer on Tuesday, which do you prefer? When you're talking about cardiac markers, read the questions. Because this one says which enzyme, and then this one says which protein marker. So which are your protein markers? Myoglobin and troponins versus an enzyme, so make sure you read it carefully. For what? Hyperuricemia is for what? Azotemia is what? several of these, I give you a patient value, and then you're gonna tell me what the problem is. One, two, three, 4, 5, 6, 7, 8, 9, 10. There are 10. For all, it's just 1 point to peaks, but you're just gonna tell me is it increased or decreased with hemolysis. So it's just an up arrow or a down arrow, or no effect. Well, so you're gonna put A, B, or C as one of your insulin scan trials. For increase, decrease, or no effect. Oh, here's another one I didn't go over. We'll just do it together. Okay, we talked about cardiac enzymes and how they're very sensitive to temperature, correct? So if you were in the lab and your machine started making loud noises because it was over temperature, what is the first thing you're gonna do?
Put a fan on.
Then what's the second thing you're gonna do?
Run controls to make sure they operate.
Correct, yes, exactly. So a technologist is running cardiac enzymes on a patient in ER. She noticed the instrument is running at a high temperature. What should she do concerning the instrument? You just told me, but just tell me again.
Put the fan on the machine, then run the controls.
Yes. And then what would you do concerning your recent patient results?
If your reagents,
If your controls are off, redo the patients.
Exactly. Exactly. We go back 3, and if those 3 are okay, you don't have to go any farther. If they are bad, you have to go all the way back to your last control value. We kind of talked about that in an earlier situation. And then the last one's, how is ammonia eliminated from the body? Oh, anyways.
Ammonia to liver, to the urea, to the kidney, and put it.
Yes. Yeah, we'll just definitely get it. But Jean's gonna beat you up over that one, because that's part of your analysis question. Other than that, I think we got it. Know your normal values. Because I give you a lot of values, and then you have to tell me what you would do with them.